Hello everyone, myself I am Susmita. I am from Artificial Intelligence and Data Science Department. Now I am going to discuss about justify why an engineering students need to know about Schrödinger and his contribution to quantum physics. Erwin Schrödinger. Erwin Schrödinger was a Nobel Prize winning Australian and naturalized Irish physicist who developed a number of fundamental results in quantum theory. From 1906 to 1910, he was the student at the University of Vienna, during which time he came under the strong influence of Friedrich Hershauer, who was Boltzmann's successor. Erwin Schrödinger work. Niels Bohr theory of the atom, electron absorb and emit radiation of fixed wavelengths when jumping between fixed orbits around the nucleus. The theory provides a good description of the spectrum created by the hydrogen atom, but needed to be developed to suit more complicated atoms and molecules. Assuming that matter, example electrons, could be regarded as both particles and waves. In 1926, Erwin Schrödinger formulated a wave equation that accurately calculated the energy level of electrons in atom. Schrödinger equation. 1925, Australian physicist Erwin Schrödinger introduced an equation that contributed greatly to the quantum mechanics. In simple terms, it describes what electrons do under almost any circumstance. To do so, one needs to insert a term that describes the situation, the V. If an electron is somewhere that nothing happens, V is 0. If it gets close to an atom nucleus, V will have a different formula. The mathematical side is beyond the scope of this article, but the result falls right within the boundary of our interest. Initially, it shows how complex the atom orbitals are, with their varying shapes as either spheres or the shape of dumbbells. PSI in the Schrödinger equation. PSI or the wave function is the most important part of Schrödinger equation, the answer. The solution to the Schrödinger equation is intended to describe the electron, and there can be infinite number of solutions. However, the focus here is on PSI, which equals the square root of pi times 2 the minus r, where r is related to the distance from the center of the atom. Classical versus quantum mechanics. Classical mechanics expect an electron to be like a planet orbiting the sun at a specific radius with a specific speed. The quantum realm not only explains why the classical view is wrong, but also shows how the reality is. Quantum mechanics has built around probabilities. The wave function or PSI is used to calculate these probabilities. However, the tricky point here is to successfully avoid interpreting the quantum realm with classical tools and expectations. The collapse of the wave functions. In this experiment, where one photon and one electron were shot at narrow slits, each acted like particles. However, when enough electrons or photons were considered, the pattern looked like a wave. In other words, the wave function specified the probability, but the observation was the point. The same things happens inside an atom. Electron can simultaneously be everywhere that the wave function says it can be. However, it is actually only at the point where it is detected. This is when the wave function collapses. This means that when the electron is finally detected, the wave function probabilities are no longer valid for places where the electron is not located. Yet, if the wave functions was spread out before the detection and not after, then the wave functions changes when the detection occurs. This is the base of collapse. Thus, the Schrödinger equation made the complex and confusing the world of quantum physics a bit more predictable and understandable. Nobel Prize winning. In 1927, Schrödinger left the positions at Zurich for a new prestigious opportunity at the University of Berlin, where he met Albert Einstein. He held that position until 1933. Options to leave upon the rise of Adolf Hitler, Nazi Party, and the related persecutions of Jewish citizens. Shortly after joining the faculties to Oxford University in England, Schrödinger learned that he had won the 1933 Nobel Prize in Physics, sharing the award with another quantum theorist, Paul A. M. Dirac. In his Nobel Prize acceptance speech, Schrödinger stated that the mentor Herschel would be accepting the award if he had not died during the World War I. Thank you.